When we're thinking about out of all the genes in the genome or out of hundreds of potential genes in a pathway, how do we prioritize biological hypotheses? It's relatively hard actually to integrate the wet lab at that scale in these, differentiated human-centric organoid models. The match isn't ideal. But as soon as we step into a specific hypothesis, right? As soon as we have an idea about a pathway, as soon as we have an idea about a target or a process, we've found surprisingly often, somewhere in the data in the real world, there are proxies for that process. And often those proxies are either drugs specifically modulating that process or known off targets, right? Like when I talk about genetics, I'll talk about pleiotropy, but I guess I'll surface it here. Drugs are pleiotropic as well, right? Drugs impact multiple mechanisms through known and unknown off targets. We have the ability to discover some of those through that chemistry platform I mentioned, but a lot of it's just in the literature. And we've been able to use that as a pivot point for specific molecular investigation into non-obvious pathways. As soon as we're there, the ability to calibrate what those drugs are doing in specific cells, in specific disease-relevant circumstances, becomes massively enabling for those real-world evidence studies. So we immediately, as we're sort of building up the DAG of the hypothesis, right, the graph that says, if you twiddle this gene in this way, if it goes up, if it goes down, we expect these markers to change in a cell, we expect these pathophysiological processes to change in a patient, we expect these outcomes to be impacted on an 18-month time frame. That's a hypothesis. Some of those arrows early on, we're not going to get in a person, maybe ever, certainly not until we go to the clinic and collect specific data, but they're cheap in a cell, right? So that ability to formulate the hypothesis and then inform different elements of the hypothesis with different pieces of evidence has been really valuable in thinking about like which of these potential real-world evidence studies are going to get us closest to the mechanism we're after. That may not be obvious in what is known in the world, that may not be obvious in the patient data, but we may be able to really incisively separate those when we go to look in the right cell type in vitro.